Hi, everyone. I'm Doug Black. I'm editor-in-chief of Inside HPC. And today we're talking with Dr. Travis Humble, sorry. He's a distinguished scientist at Oak Ridge National Lab, where he's director of the lab's Quantum Computing Institute. And Dr. Humble, welcome. Thanks for joining us today.
Oh, thanks, Doug. Thanks for having me on.
Okay, so Travis, tell us if you would the area of quantum computing that you're working in and the research you're doing, the research that you're doing that you're most excited about that has what you would regard as the greatest potential.
Quantum computing is a really exciting area, so it's hard to narrow it down to just one example. This is the intersection of quantum information, quantum mechanics with computer science. We've already recognized that we can accelerate solving scientific applications using quantum computers. At Oak Ridge, for example, we have already demonstrated examples in chemistry, material science, high energy physics, where we can use quantum computers to solve problems in those areas. These demonstrations are just early examples of how we expect quantum computers can take us to the most challenging problems for scientific discovery. My own research is actually focused on how we could integrate quantum computers with high performance computing systems. Of course, we're adopting an accelerator model at Oak Ridge where we're thinking about using quantum processors to offload the most challenging computational task. Now, this seems like an obvious approach, the best of both worlds. But the truth is, there's a lot of challenges in bringing those two systems together.
Oh, well, I have no doubt there is. and But it sounds like sort of a hybrid approach, almost a CPU, GPU, only we're talking systems writ large. Tell us about DOE's and Oak Ridge's overall quantum strategy and how the Quantum Institute works with vendors and academic institutions on quantum technology development.
The Oak Ridge National Laboratory has played an important role within the DOE's National Laboratory System, leading both research and infrastructure. Of course, in 2018, the president announced the National Quantum Initiative, which was intended to accelerate development of quantum science and technology in the United States. Oak Ridge has taken the lead in the development of research, especially software applications, hardware, for how quantum computing can address scientific discovery. At the same time, we've helped DOE establish a quantum computing user program, something we call QC-UP. This is administered through the Oak Ridge Leadership Computing Facility, and it looks for the best of the best in terms of approaches to how quantum computers could be used for scientific discovery. We provide access to the users through the user program in order for them to test and evaluate how quantum computers might be used to solve problems in basic energy science, nuclear physics, and other areas.
Okay, great. So how far would you say, I always ask everyone involved in quantum this question, but how far are we from practical quantum computing and from what's referred to as quantum advantage, where quantum systems can run workloads faster than conventional or classical supercomputers?
Oh, this is such a great question. Quantum advantage, of course, is the idea that a quantum computer would be able to outperform any other conventional computing system on the planet. Very early this fiscal year, so back in October, there was an announcement from Google where they actually demonstrated an example of quantum advantage using their quantum computing hardware processor. Oak Ridge was part of that announcement because we used our Summit supercomputer system as the baseline to compare that calculation. But here's the rub. The Google demonstration was primarily a diagnostic check that their processor was behaving as expected. And the Summit supercomputer actually couldn't keep up with that type of diagnostic check. But when we look at the practical applications of quantum computing, still focusing on problems in chemistry and material science and other scientific disciplines, we appear to still be a few years away from actually demonstrating a quantum advantage for those applications. This is one of the hottest topics in the field at the moment, though. Once somebody can identify that, we expect to see a great breakthrough in how quantum computers can actually be used in these practical areas.
Okay. So how did you become involved in quantum in the first place? Tell us a little bit about your background in technology.
I actually started early on studying quantum mechanics through chemistry. My focus early on in research was on theoretical chemistry and understanding how molecules behave quantum mechanically. What has turned out to be one of the greatest ironies in my career is that quantum computers are actually significant opportunities to solve chemistry problems using quantum mechanics. So I got involved in quantum computing relatively early. Certainly, the last 15 years or so have been a roller coaster ride, mainly going uphill in terms of developing quantum computers and looking at the question of how they can intersect with high performance computing. Being at Oak Ridge, that's just a natural question for me to kind of come across. I work every day with people who are using some of the world's fastest supercomputers in order to solve the exact same types of problems that we think quantum computers would be best at. So for me, the intersection between those two areas just seemed like a natural path to go down.
I see. Okay, is there any other topics related to all this that you'd like to add?
I think that quantum computing has a certain mystique around it. It's an exciting area, and it relies on a field of physics that many people don't yet know about. But I certainly anticipate that in the future, that's going to change. This is a topic that's probably going to impact everyone's lives. Maybe it's 10 years from now, maybe it's 20 years, but it's certainly something that I think we should start preparing for in the long term. And Oak Ridge is really happy to be one of the places that is helping lead that change.
Great stuff, Travis. Well, thanks so much for your time. It was great to be with you.
Oh, thanks, Doug. Great to talk with you too.